angle ABC is equal to 69 degrees and angle ACB is equal to 31 degrees. Let me draw these. Please write the question. Write it like this. Given is this. To find is this. Okay. And then make a circle. They have not given us over here that BC is the diameter. So we cannot assume that BC is the diameter. So BC is like some chord. This is BC. And this is 69 degrees. So this is a point A. This is a point D. Okay. We're going to connect AD and AC. Supposed to be a straight line. Then we connect a BD and DC. So this angle over here, this one is 69 degrees, angle ABC. And then the other one, the small angle over here, is 31 degrees. Okay, so first think about this, think about all that we have studied till now. Flip through your pages, flip through the theorems, look at them, tell me if there's something useful that we can apply here. Which angle do we have to find first of all? We have to find angle BDC, which is this angle. Okay, so let's do one thing. Let's forget about this triangle. Okay, can you tell me something, triangle ABC? What can we do in this? Think about it. Very simple. Just give it a try. Even if it's not the right answer, it's fine. Give it a try. Can we do something in this triangle? Abdul Jabbar?
Yes, ma'am.
What can we do in this triangle ABC? Array, it's very simple. You just have to find this angle. Yes or no? Can we find the angle A from here?
Yes, ma'am.
Yeah, we can find it. How can we find it?
Ma'am, angle A.
Angle sum property. Yes.
Yes,
So
ma'am.
in triangle ABC, first of all, why are we finding angle A? They had asked us to find, they had asked us to find angle, this one, the blue angle they had asked us to find. Why are we finding angle A? Will someone tell me? They had asked us to find the blue angle, angle BDC. Why are we finding the other angle, angle A? Why am I asking you to find that? Those who were present in the previous classes, come on. Angles in the same segment are equal. Remember or forgot? We even proved it. Angles in the same segment are equal. Okay. So, to find angle BDC, we can first find angle BAC. Why? Because since angle BAC is going to be equal to angle BDC. Is this point clear to everyone? Is this point clear to everyone?
Yes, ma'am.
Abdul Jabbar, what happened? It's not clear to you? Tell me where is the doubt.
It's clear, ma'am.
Then say yes, no. Abdul Rahman, what happened?
Oh, I was absent last evening when
Then say
meeting.
that I didn't understand. Okay. And if you were absent, Abdul Rahman, it is your duty to look at the recordings. So next, so basically we can first find angle BAC. So we can first find angle BAC. I am making this figure again. You don't have to make it again. You can just get it done in the same figure. So you can first find angle BAC. So in triangle BAC, by angle sum property, what do we have? Someone please calculate and tell me what will be angle BAC. Hmm.
Right, ma'am.
So if angle BAC is 80 degrees, so angle BDC will also be 80 degrees because of this reason. Angles in the same segment are equal. Okay. Shall we move on to the next one? Shall we move on to the next one?
Yes, ma'am. Yes, ma'am.
Okay. Once again, as I repeat in every class, if there's any point that you're not understanding, or if anything that you want me to repeat, any doubt you have, please ask, okay? Okay. So in this figure, we have a chord again, and we have this angle. Please draw the diagram. Then we have this chord. So this is D, A, D, C. Now, this angle over here, let's call this point as E. This angle they're saying is 130 degrees. And angle ECD is 20 degrees. And they are asking us to find angle BAC. Angle BAC is this one. Okay, now you all please think about it. Take a minute to think about it. Abdul Jabbar, any idea? Okay, fine. So see, if you look at this angle over here, this blue angle, okay, angle AEB. Can we find angle AEB? Angle AEB is going to be 50 degrees. And similarly, this one is also going to be 50 degrees. Why? Can someone tell me why? Why will this be 50 degrees? Come on, this is very basic stuff. I want at least one person to answer. Why is it going to be 50 degrees? This one. Abdul Jabbar. Abdul Jabbar.
Yes, ma'am.
Why is it going to be 50 degrees?
Mm,
Hmm? Fine. Forget about everything else. Now, can you tell me why is it going to be 50 degrees? This blue angle.
ma'am, angle AEB,
Yes, AEB.
ma'am,
This
because
blue angle.
180 minus 130 got 50.
Yes, linear pair, right? So
Yes.
what was taking so long? See, when you have a complicated figure like this, please don't get uh, distracted by all the other elements in the figure, okay? So this angle is 50. So by vertically opposite angles, we have this angle is also going to be 50, right? So from here, can we find angle D? So let's write it like this. First of all, the first step is, since angle BEC is equal to 130, therefore angle AEB is equal to 180 minus 130 is equal to 50. Please write the reason also in the bracket. Linear pair. the next step, the next step is angle this one. Or we didn't actually need this. We can say angle, instead of saying angle AEB, you can say angle DEC. DEC, this one. Okay. Angle DEC is going to be 50 because it is linear pair with angle 130. So we can find angle D from here in triangle EDC. You can find angle D. Which one is angle D? It is this purple angle, okay? The purple angle is angle EDC. So in triangle EDC, angle EDC is equal to 180 minus 50 plus 20, right? By angle sum property. See, we're running quite behind in the syllabus, so I'm going to go a little quickly. So therefore, I expect that if I ask a question, you guys must answer. If you don't know the answer, please unmute and say that you don't know. I shouldn't have to wait for you to reply, right? And because see, if this was a physical classroom, you could have very easily just nodded or you could have just shook your head. I would have known ki, okay, fine, you're understanding or you're not understanding. But since this is not a physical classroom and I can't even see you, since you guys don't want to switch on your cameras, so I can't even see you. So I don't know whether you're understanding or not. So I expect that when I ask a question, at least you can respond. Okay. So we are going to go a little quickly. If there's any doubt, please ask. Please unmute and ask, or please write it in the chat box, whichever is more convenient for you. So angle EDC is going to be 180 minus 70, which is 110 degrees. So now since we have found angle EDC, the purple angle, the top right angle, so angle BAC is going to be the same angle, right? We have to find angle BAC. It's going to be the same because angles in the same segment are equal. So now angle BAC is equal to angle EDC, since angles in same segment are equal. Therefore, angle BAC is equal to, how much was EDC? This one, 110 degrees. So that's the final answer. Okay, next question. ABCD is a cyclic quadrilateral. Cyclic quadrilateral, what is it? A quadrilateral which all of whose vertices lie on a circle, the same circle. So this one is going to be a cyclic quadrilateral. A, B, C, D. So the figure is not given in the question, but we need to read the question step by step. And as we are reading each piece of information, we need to translate that into geometry, into a diagram. So A, B, C, D is a cyclic quadrilateral. Whose diagonals intersect at a point E. So remember, the moment they talk about cyclic quadrilaterals, the first thing you should remember is, okay, opposite angles in a cyclic quadrilateral are they equal or supplementary or complementary? Opposite angles in a cyclic quadrilateral are supplementary, okay? So they intersect at a point E. So fine, this point is E. If angle DBC is 70, DBC means this one. Just a minute, this one. This angle is 70. And angle BAC is 30. BAC, this one is 30. Find angle BCD. Angle BCD means this big angle over here. Find angle BCD. Further, if AB equals BC, find angle ECD. So fine. So the further wala part, we will come to it later. Let's first talk about the finding angle BCD. Okay. So we can look at it like this. Angles in the same segment are equal again. So angle, if you look at forget about this. Okay. Look at these two angles. Look at the fact that BC is a chord. Okay. It is subtending two angles over here, one over here and the other one this one. So one is this angle and the other is this angle. BC is a chord subtending angles at two different points. So these two angles are going to be equal. Why? The same thing which we have been using in the previous questions. Angles in the same segment are equal. Meaning, once again, for those of you who didn't attend the previous class, I will just quickly revise it. If there is a line segment, a chord, sorry, if there is a chord of the circle which subtends two different angles, matlab two angles at two different points in the same segment. Same segment meaning both of them have to be on the same side of this chord. Okay, it can't be like one angle is over here and the other is over here. It can't be like this. No, they are talking about when both the angles are in the same segment. So they are saying that both of these angles are equal. Angles in the same segment are equal. So both of these are going to be equal. This is the thing that we have been using. So since BC is a chord here, the vertical one, it is subtending two angles. This angle, angle A and angle D. So they are going to be equal because angles in the same segment are equal. So first of all, angle A, no, angle BA, what is this? C is going to be equal to angle BDC because since angles in the same segment are equal. Everyone understood till here? Yes or no?
Yes, ma'am.
Good. Do I have to call everyone by name? Abdul Jabbar, Zain.
Yes, ma'am.
Okay, so that means angle BDC, therefore angle BDC is going to be equal to what? 30 degrees. Fine. So it's equal to 30 degrees. I'm going to write that over here. Now we had to find the purple angle, right? To find angle BCD, right? That's what the question was asking us, to find angle BCD. So we can just ignore this line segment and think of this triangle 30, 70, and that purple angle. Can someone quickly tell me how much will that purple angle be? Apply angle sum property. See, 30 plus 70 is how much? 30 plus 70 is how much? Avni, what is 30 plus 70?
30 plus 70 is 100.
100, right? So you do 180 minus 100. 180 minus that sum which you have added. What is 180
80.
minus 100? 80, right? So the purple thing is going to be 80. Purple angle is going to be 80. Okay.
Okay.
So in, please write it down, in triangle BDC, angle by angle sum property. Angle BCD is going to be 180 minus the sum of 70 and 30 is going to be 180 minus 100, which is 80 degrees. So this is angle BCD. If you want me to go slow, please tell me.
Ma'am,
The
it's
goal,
okay.
it's okay, fine, good. So next part of the question isn't over yet. It says further, if AB equals BC, so now they have given us one more condition, that AB equals BC. So AB is this, BC is this. AB equals BC. Find angle ECD. What is ECD now? This thing now. ECD is ECD is this one. No, ECD, yes. ECD is basically the same thing as ACD. This is what we have to find. Find angle ECD. In bracket, I'm writing angle ACD just so that we don't get confused. Oh, wait, sorry. It's ECD, na? Not ECB. ECD is the other one. This one. Okay. ECD. ECD. Yes. ECD, which is the same thing as ACD. Okay. So now, if these two angles are if these two sides are equal, can you look at this triangle? Triangle ABC. In triangle ABC, can someone tell me what kind of a triangle is this? Triangle ABC. What kind of a triangle does it look like? Look at the
Equal.
side.
Isosceles.
Very good. In triangle ABC, or we can say triangle ABC is an isosceles triangle since AB equals BC. And we know one thing about isosceles triangles, something about the angles. What is it? Hmm. What do we know about the angles of an isosceles triangle?
Two angles are equal and one angle is not.
Very good. So in other words, we can say that angles opposite to equal sides are equal, right? Please write it down. Angles opposite to equal sides are equal. Therefore, this angle over here, the C wala angle, angle ACB is going to be equal to angle CAB, which happens to be 30 degrees. Okay, so that means our angle ACB is 30 degrees. Now, if ACB is 30 and we know that the entire angle is 80, because angle BCD, we had found it in the previous part of the question, this one, that angle BCD from here to here, the entire angle is 80 from here to here. The entire angle is 80. So if a part of the angle is 30, the remaining part will be how much? I think you didn't understand the question. Let me redraw the diagram, okay? So this is your angle. This is DCB. This is E. Okay, now look very carefully. This entire big angle which I've drawn here, this is 80. It's written over here. Angle BCD is 80. From here you can see. Angle BCD is 80. And just now we have written that angle ACB, as you can see, ACB, this one. Angle ACB from here to here, this much is 30 degrees, sorry, 30 degrees from here to here. So can someone tell me from here to here, angle ACD is going to be how much?
Angle
ACD is going to be how much?
the
The
whole
green,
angle is 80, right?
yeah, the whole angle is 80. The one
So
which I've
ACD will
marked,
be 50.
50 degrees. Very good, Apni. So it's going to be 50 degrees, right? So see, whenever you get confused because of a lot of lines and a lot of things getting intersected with each other, just make this portion which you want to focus on, make it separately, make it in a rough column or something, okay? So let's write that. So angle ACD is, as you said, 50 degrees. So that is what we had to find, right? That means Angle ECD is 50 degrees. Shall we move on to the next question? Yes? Okay. Next question also, we have to write it. We have to make the diagram. We could have done it in another way, right? This is a cyclic quadrilateral. So, no. Is it given? Quadrilateral. So, no, we could not have done it in another way. Whose diagonals intersect? Just a minute. Yeah, fine. The diagonals of a cyclic quadrilateral are, if the diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, then prove that it is a rectangle. What does that mean? So let's first draw a circle, and now we need to draw a cyclic quadrilateral, but in such a way that the diagonals are diameters through the vertices of the quadrilateral. So diagonals are diameters. So you cannot, for example, in this case, look at this. Hmm? The previous question. This was a cyclic quadrilateral, but look at the diameters. Are they passing through the center? Because diameter means what? It passes through the center, na? But in this case, is it passing through the center? No. The center of the circle is somewhere around over here. Only one of them is passing through the center, the other one is not passing. So this quadrilateral is not a rectangle. But if there is a quadrilateral in which the cyclic quadrilateral in which the diagonals, they pass, both of them, they pass through the diameter, then that quadrilateral happens to be a rectangle. So let's first make the center. Let's make the diagonals next. So this is one diagonal. This is another diagonal. And they pass through the center, right? Because they are both diameters. Now let's make the quadrilateral itself. We need to prove that it is a rectangle. See, it doesn't have to be at 90 degrees. I have drawn it at 90 degrees. If it is at 90 degrees, then it is going to be a square. But if it's not at 90 degrees, I'm just going to draw a small version of it. Let's say one of them is going like this, and the other one is going like this. Again, both of these are diameters, right? Diameters of the circle. So if you just make the quadrilateral, you can see that it is again a rectangle. So you see, a square is also a rectangle. So this one has an added condition that it is 90 degrees. So if it is 90 degrees, it will be a square. And we know that, and we have studied this in previous classes, that a quadrilateral in which the diagonals are at 90 degrees is going to be a square. So I'm going to remove this one, and we're going to, you can have, if you have already drawn the other one, don't erase it. That one is also valid. This one is also valid. So let's just make the quadrilateral P, Q, M, N. Or let's make this as PQ, this is a chord PQ, and this is a chord MN. Okay. Okay. So they are saying that the diameters pass through the the diagonals pass through the diameter. Now we know one thing about diameter, that the diameter subtends an angle of 90 degrees. Yes. So if this is the diameter, then the angle it is subtending, which is this one, is going to be 90 degrees, right? This angle is going to be 90 degrees. Okay, for those of you who do not remember, let's revise it. See, a chord, let's say a random chord anywhere, it can
Angle
subtend
M
any
will
angle.
be 90
Yes,
degree.
Abdul Jabbar?
Angle M will be 90 degrees because
Yes, angle M is going to be 90 degrees, and anything else?
now angle Q.
Yes, angle Q will also be 90 degrees. Okay, so just a minute. Hmm. So what were we seeing? Yes. So we were revising this thing. Ki if there's a chord, it subtends an angle over here. This angle could be anything. But if this chord happens to be the diameter, then the angle it subtends anywhere on the circle is going to be 90 degrees always. Whether it is at the top or at the bottom, this angle is going to be 90 degrees always. The angle subtended by the diameter is always 90 degrees. Okay.
So vertically opposite angles will be 90.
Where are we finding vertically opposite angles here?
From the figure you drawed before, though
Hmm.
those vertically opposite triangle, in the triangle, the vertically opposite was equal. That's why I asked.
Acha, wait, just now which I had drawn, this one. But these are
Yeah.
not vertically opposite now. Remember, what is vertically opposite? Vertically opposite angles means X. This and this are vertically opposite. Okay?
Okay.
These are not vertically opposite. They are called opposite, but there's a different type of opposite. This is opposite angles of a quadrilateral. And we know that in a cyclic quadrilateral, the opposite angles are going to be supplementary. So if one of them is 90, then the other one is also going to be 90 because of the fact that it's a cyclic quadrilateral. Okay.
Okay, ma'am.
Hmm. So hmm, what we can do is, so let's write it like this. Given, and I'm going to write this point as O. Given, we can prove it in a different way actually, because if we prove it like this, then we will also have to prove one more thing, which is the fact that this is equal to this side is equal to this side. We'll have to prove that. So instead of that, so we'll have to prove two things. So instead of proving two things, let's just prove one thing, and that is as follows. Given uh, N, P, and M, Q are diameters of the circle, okay? Then you have to prove that it's a rectangle. So I'm just gonna write to show that whatever P, Q, N, M is a rectangle. All right. So first, let's write it like this, proof. So, okay. So what we are trying to prove, let's try to prove that the diagonals are bisectors of each other. Matlab, they are equal. If we prove that the diagonals are equal and they bisect each other, then we will be able to show that this is a rectangle. Because if you remember from your previous class, class 7th and class 8, we studied that diagonals of a rectangle are equal and bisect each other. So if we prove that we can prove the fact that this is a rectangle. So we need to prove that these, well, obviously NP is equal to MQ, right? Because they are diameters and diameters are equal. Yes, diameters of the same circle are obviously going to be equal. Just like we say that radii of the same circle are equal, similarly diameters of the same circle are equal because it's twice of the same radius. So diameters of same circle, that's why they are equal. So this is there. And we need to show that they bisect each other. Well, that is also pretty obvious, right? Because OM is equal to OQ. Why? Can someone tell me why is OM equal to OQ? Why is OM equal to OQ? Remember the fact that this is a circle we are talking about. Yes, Avni?
OM is equal to
OQ.
OQ.
Why?
Hmm.
Acha, what is OM of the circle? OM is dash of the circle.
Radius.
Very good. And OQ is
Again radius.
again radius. So they will be equal. So OM is
Diameter.
equal to OQ because radii of the same circle, right? They are both radii of the same circle, so therefore they are equal.
Yes.
That means this line segment MQ is bisected by the line segment NP. Similarly, bisected means what? It's being divided into two equal halves. Similarly, NP is bisected by MQ. If you're not understanding, please ask. Since NO is equal to OP is equal to radius, radii of the same circle. So what we have proven, therefore, diagonals of quadrilateral PQNM are equal and bisect each other. Therefore, PQNM is a rectangle. Another way we could have proven it, would be that the thing we were doing, that this is 90 degrees. This is 90 degrees. And if we look at these two triangles, this one and this one, okay, then you can show that they are both congruent to each other. How? Because, let me show you. Let me show you just a minute. This triangle and this triangle are congruent. Can someone tell me why? See, this side is equal to this side because radius equal.
Yes.
This side equal to,
NP is equal to MQ.
yeah, right now we are talking about these two triangles, okay? So you will say MO, which we have written here. MO is equal to OQ, radii. And NO is equal to OP, radii. So in these two triangles, we are showing that they are both congruent by showing that MO is equal to OQ, NO is equal to OP, and these two angles are vertically opposite angles. So by SAS rule, these two triangles are congruent. If they are congruent, that means by CPCT, this side is going to be equal to this side. And so we have gotten a quadrilateral, this quadrilateral, in which opposite angles, one pair of opposite angles is 90 degrees and one pair of opposite sides is equal. Therefore, this has to be a rectangle. So they are talking two ways of doing this. We did the one which was easier. In this, you don't have, in the way which we have done this one, you don't have to prove any congruence or anything. So this one was pretty simple. All right. So, so do you guys want to do a few more questions? Yes. Shall we do a few more questions, or do you want to call it a day?
Let's call it a day.
Acha. Okay. Since we started a bit late, I was hoping that you guys would study up a little, like 10-15 minutes more, but okay.
Now we can do another question.
Chalo. We'll do just one more question, okay? Let's do a simple one. Let's not do any of these exercise questions. Blah, blah, blah. Uh, prove. Prove that questions are pretty boring, na? So let's do something else. Let me think of a question. Just one more. Okay, this is a very basic one. Let's do it. In this question, nothing special is given. There's no special information being given to you. You have to just this is angle B, this is angle A, this is capital A, capital D, capital C, O. You have to find A plus B. Okay. So we're going to use something which we did in the previous exercise. Who will tell me? Yeah. See.
Intersect AB, AO.
Acha, if we intersect AO, then what's going to happen? See, one thing which we can do is we can so this is angle A. So who will tell me how much will this angle be? This one which I have marked. Angle BOC is going to be how much? Abdul Jabbar? Yes, Avni. If this angle is A, this is going to be how much? This is going to be 2A, right?
Yes.
So please note down this question. And then after that, write the answer. Angle BOC is going to be equal to 2A. Because the theorem that we studied, that angle subtended at the center is double the angle subtended at any other point of the circle. So this is going to be 2A. And now since this pink triangle, look at the pink triangle, is an isosceles triangle because both of the two sides are radii, right? So it's an isosceles triangle. So this is also going to be B. This is also going to be B. So by in triangle BOC, by angle sum property. Can you tell me by angle sum property what will we have? Something plus something plus something is equal to 180. Who will tell me? Hmm.
2A.
Yes.
plus A.
I'm talking about the pink triangle. Look only at the pink triangle.
2A plus B
Plus B
plus B is
plus
equal to
B. 180. Very good. So what does this become? So 2A is 2A and B plus B is
B square
B plus B is
B.
2B. Good. So 2A plus 2B. So take 2 as common. A plus B is 180. Hmm?
A plus B is
Then
equal to 180 by 2.
180 by 2 and that is
A plus B is equal to 90.
90 degrees. Very good. So they had asked you to find A plus B. So A plus B is 90 degrees.
Yes.
Okay. I'll give you a similar question in for homework. Just note down this question. Okay. So pretty simple. I think I had already given you this question. I don't remember. So one thing is that you guys don't complete your homework. That's gonna be pretty problematic, now. So this is a chord. I made it slanting by mistake. You please try to make it straight. AB. I mean, it doesn't matter. It's the same thing. It's a circle, right? So it's the same everywhere. This is E. This point, this angle we don't know. Oh, no, wait. BEC is 100. Okay, so this angle is 100 degrees. I'm gonna do one thing. This is Y. This point over here. No, wait. Center O. Over here is center O. So this is passing through the center. Wait a minute. This is O. AB is equal to AC. So AB is equal to AC is given. And find the values of X and Y. So this is Y and this is X. Let me give you a hint. If AB equals AC, what will this, if you forget, ignore the pink part, okay? If AB equals AC, then what can you say about this angle ABC? It's going to be equal to, angle ABC is going to be equal to, this angle is going to be equal to, if AB equals AC. What happened? Slept off. What kind of a triangle is ABC?
Isosceles.
So angle ABC is going to be equal to,
Angle ABC is equal to angle BEC.
no,
Oh
it's going to be
yeah,
equal to
angle ABC is
X,
equal to angle ACB.
and that is X, right? So this is also going to be X. Fine. So